In this investigation, we will explore the effect of the variables a, b, and c on the graphs of y is equal to a sin bx plus c, y is equal to a cos bx plus c, and y is equal to a tan bx plus c. We do this to understand the effect of the variables a, b, and c on these types of graphs. To do this, we use the geometer's sketch pad. Firstly, we will make sure that we are using the arrow tool. Then we will go to the upper left and select the Graph tab, go down to Grid Form and insert a rectangular grid. We take note that this will be unit point 1, unit point 2, and unit point 3. By dragging unit point 2 towards unit point 1, we can increase the range of the x-axis. We would like our range to fall between negative 500 and 500. Thus we will drag until we reach our desired range. For the y-axis, we would like our range to be between 4 and negative 4. Thus, we will drag unit point 3 away from unit point 1 until we reach our desired range. Now we will start to draw our graphs. Now we will be drawing our 3 sin graphs. To start, we will go to the Graph tab in the upper left, scroll down and select Plot New Function. Then, going to the Function scroll down list, we will select sin x. Select OK, and when asked if you'd rather switch your preferred angle units from degrees to radians, select No. This will be our first sin graph. Remember to right-click on our line and go down to Label Function Plot and insert the name of our first graph. Then, repeating the same steps as the first, we will go to the Graphs tab, Plot New Function, and in this case we will plot 2 function sin x for our second graph. Select OK and right click and label our second graph as y is equal to 2 sine x. Select OK and move your label to your desired spot. Then, by going for our third time to the graph, we scroll down to Plot New Function and we insert 3 sine x. Click OK and right click and label function plot as 3 sine x. Now, in order to save this image, we will select or click Windows and Print Screen at the same time. We will now be able to find our captured image in the Screenshots folder, which is in the Pictures folder on your PC. Opening this, we can clearly see our captured graphs. For clarity, you may rename this as your sin graphs. or any such name. This can now be used to answer question 1. Then, for task D, we would like to repeat this layout for the graphs of y is equal to a cos x and y is equal to a tan x. In order to capture our grid without our three functions, we will simply go to Edit in the upper left and undo our three constructions. Now that we have our blank grid, we may continue with our three cos graphs. To start, we follow the same steps. Graph, plot new function, and we select functions cos x for our first graph. We may label our function plot cos x. Then, going again to graphs, plot new function, we can make a 2 cos x graph and label our function plot in the same manner. For our last graph, we just repeat the same steps and we create our 3 cos x graph. And label in the same manner. Press the print screen and the Windows button at the same time and you will now find your new one in your screenshots folder, in your pictures folder, and you may want to rename this as your cos graphs. We will now repeat the same steps for our 3 tan graphs. Again, in order to have a blank grid, we will just go to Edit in the upper left and undo 3 times. Then we will go to Graph, we will plot a new function, and in this case we will plot tan x. Then we will again go to Graph, plot new function, and in this case we will plot 2 tan x. Lastly, we will again go to Graph, plot new function, and we will plot 3 tan x and select OK. In this case, we will name our 3 plots tan x, to tan x, and lastly three tan x. Again, we will use our Windows button and our print screen in order to capture our image. And going to the Screenshots tab, we have now captured a screenshot of our tan graphs, which we might name tan graphs. Now we may use these three graphs in order to copy and complete the table given in question 2. We can now attempt to answer the question, how does the value of A affect the different graphs? Then, moving on, we will now be changing the period of the trigonometric graphs. We will repeat A, B, and C for the graphs of y is equal to sine bx, y is equal to cos bx, and y is equal to tan bx, for b is equal to 1, 2, 3, a half, and a third. We will do all of this on the same screen. To start, to work with your grid, we will go to Edit and we will undo our 3 tan graphs. Now we may work with our clean grid once again. We will now be plotting all our sine, cos, and tan graphs by changing the period of the trigonometric graphs. To start, we go to Graph, we plot a new function, and we plot our basic sine graph, where if asked this question, we just select no. Remember to label your sine graph. For the next graph, we go to Graph, we plot a new function, and we plot our sine 2x graph. And we label our function plot as our sine 2x graph and select OK. Then we again go to the Graph tab, plot a new function, we select Functions, Sine, and in this case we are plotting our sine 3x graph and select OK. And we right click, label function plot, and we label this one sine 3x and select OK. Then we go to our Graph tab, plot a new function, and in this case we will be plotting our sine a half x graph. And we will label it as such. Lastly, in the sin series, we will go to Graph, plot new function, sin, and we will plot a third x. Press OK and label our last sine plot as sin a third x. Then we will start our cos range of graphs by going to Graph, plot a new function, go to the Functions drop-down and plot cos x. And remember to right-click, label function plot and name this cos x. Then we can go to our Graph tab, plot new function, and in this case we will be creating our function cos 2x. And remember to label your function cos 2x. Then we will be going again to Graph, plot new function, and again we will do our cos 3x graph. And remember to label each plot, as otherwise it might get confusing. Now we go and we graph, we plot a new function, and we plot our cos a half x, press OK, and we label this as cos a half x. Then we graph, we plot a new function, and we create our cos 1/3 x, and we remember to label our plot. The nice thing about labeling our plots as we go is if you are looking for a specific graph, clicking on the label will have our graph highlighted. Lastly, we will do our tan graphs. We will click on Graph, plot a new function, and we will plot our basic tan x graph. And we will label this tan x. Then we will graph, plot a new function, go to Functions, tan, and we will plot tan 2x. And we will label our function as tan 2x. Then we will go to Graph, plot a new function, and label this one as well as soon as we're done. Then we will go to Graph, plot new function, and in this case we will plot tan a half x. And we will remember to label our function tan a half x. Then we will again go to graph, and for one final time we'll go to plot new function, and we will plot tan a third x. This can be a valuable tool in answering the questions that are given in the table below. Can you now explain how the value of b affects these graphs? Now, for our final part of this investigation, we will be repeating steps A, B, and C for the graphs of y equals sin x plus c and y equals cos x plus c for c equals 1, 2, -1, and -2. We will again do every function on the same screen. To start, we will want to use our grid without all of our previous graphs. To do this, we can go to Edit, and we can undo the construct function plot. We will do this for every graph, or we will go to the shortcut Control Z to do it a bit quicker. We are now back at our clean grid, and we can start on the next section. We will now complete our final set of graphs in this investigation. Firstly, we will go to Graph, Plot New Function, and we will plot sin x. Right-click, label function plot, and we will call this function sin x. Then, following the same steps, graph, plot new function, we will go to our functions and we will plot sin x plus 1. Select OK, and remember to label your function plot. Following the same steps, plot new function sin x plus 2. Label your function plot as sin x plus 2. Then we go again to graph, we plot a new function, and we plot function sin x minus 1. If your function happens to look incorrect or not alike in the investigation, you've made an error, and you just need to quickly insert the right function. Right-click, we label our plot as sin x minus 1. Then again we go to graph, plot new function, and in this case we plot sin x minus 2. Right click, label function plot, and we label this as sin x minus 2. We are now complete with our sine series. Moving on, we go to graph, we plot a new function, and we plot our basic cos function. Right click, label your Then, following the same steps, graph, plot new function, we plot our cos x plus 1 function. And we right click, we label this as cos x plus 1. Next we go to graph, plot new function, and we plot cos x plus 2. Then we label our function as cos x plus 2. We go on following the same steps, cos x minus 1. And we insert our label function plot. And for our last graph, we go to graph, plot new function, cos x minus, again, make sure that your function looks like the one in the investigation, and we say cos x minus 2. Select OK, right click, label function plot, and we name this our cos x minus 2 graph. We can now use this in order to complete our table, and in summation we can explore these graphs and explain how the values of A, B, and in this case C affect our graphs.